Hello, welcome to this video. This is 3-4 and we are going to find derivatives of inverse functions. Now, some prior knowledge for this, hopefully you've worked with inverse functions before, how to find inverse functions. What does it even mean to be an inverse? Well, I want you to kind of anchor your knowledge in the idea of how do I undo addition? Subtraction. How do I undo multiplication? Division. Those are inverses. And if we're talking about functions, they will undo each other. Now, the main idea in undoing or finding inverses is switching x and y. We switch x and we switch y. So let that serve as your foundation today. But in this lesson, what we're going to do is we're going to go ahead and explore a couple of different ways in order to find the derivative of an inverse function. And once we look at these approaches, the goal is for you to understand how the derivatives of inverses work, regardless of what representation you're given in the problem. Now, I'm going to start off looking at a visual representation of a function that we have here. We have f of x, that is this function, and we have its inverse, which we call f inverse of x. Here it is. And what you'll notice is that these functions are mirror images across the line y equals x. And if you are in my class last year, you went ahead and graphed things like this, and we made you point out, hey, if they intersect, they're going to intersect on this line y equals x. Now, the key thing for our lesson today is to notice that a point contained on graph f, a comma b, this point right here, its mirror point is on f inverse, and that mirror point is b comma a. And this should make sense is because points on their inverse, right, we switch x and y. So those points are going to flip and mirror across this line y equals x. Okay, and just from the graphs, do you see a relationship between the slope of f at a comma b and the slope of f inverse at b comma a? And I'll just go ahead and I'll draw a quick little tangent line. You can see the slope there for that function, and then the slope here for this one. Is there any type of relationship between those tangent lines? That's what we're going to investigate today, and we're going to answer that question. Let's go ahead, let's start out looking at example number 1. And example number 1 says let f of x equal the square root of x. Okay? Go ahead and sketch the graph of f of x. All right, well, the square root of x, that's just a radical, 0, 0, 1, 1, 4, comma 2. I can plug in those points and I get this graph. That should be prior knowledge. You should be familiar with that. Okay, and right here is f of x. And then in B it says find f inverse of x. You must restrict the domain. Okay, well, if I want the inverse, one thing is to just think about it kind of conceptually. What's the inverse of a square root? A square. Now, if you're not buying that, something that we did last year was we went ahead and we switched x and y in order to find the inverse, and then we solved for y. So if I go ahead and square both sides, we get y is equal to x squared. So there is the inverse. This right here is f inverse of x. That's x squared. Now, they talk about restricted domain. This is important, but in the grand scheme of things, it's not going to be a main component of our lesson at all. Just remember that our x values have to be greater than or equal to 0. And the reason for that is I can only have 1/2 of my function, x squared, because if I draw the mirroring, I want that also to be a function. And if I had both pieces of a parabola, the inverse would not be a function. So we restrict the domain. Again, like I said, not a big deal. C, they say sketch the graph of f inverse in the coordinate plane. Okay, so I'm going to go over here to my coordinate plane, and I'm going to graph f inverse. Well, that was a quadratic, so 0, 0, 1, 1, and 2, 4. That's right up here. So here's my parabola, and this is f inverse of x. Okay, so there's a function, and its inverse. Beautiful. Notice they intersect on that line, y equals x. Okay, and then D, we're asked to go ahead now and to differentiate both f of x and f prime of x. Well, f of x is the square root of x, and that derivative, f prime, we could go ahead, you could use the power rule, right? X to the power 1/2, bring down the 1/2, drop the power by 1. Okay, but I think hopefully at this point it's kind of common convention. There's our derivative. Okay, so I went ahead and differentiated it, and then now I'm also going to differentiate f inverse of x, which is x squared. That one is a little less cumbersome. Okay, the derivative of x, that's 2x. All right, and then part E, they say find the slope of the graph of f at 4,2, and the slope of the graph of f inverse of x at 2,4. And what I want you to note about this is these are mirroring points. They are inverses of each other. X and y has been switched. Okay, and I just want you to see here, f prime, if I plug in this x value, 4, that's 1/2 times the square root of 4, which is 1/4. 1/4. Okay, and then now what I'm going to go ahead and do is I'm going to plug in this x value into the slope of my inverse. Okay, and that's 2 times 2, which is 4. And then here's the part in the lesson where I say, what do you see? What do you notice? What do you wonder? And here you can pause me and you can try that. Hopefully it doesn't take you too long. But the relationship between these derivatives, 1/4 and 4, is that they are reciprocals. They are reciprocals. And that's the conclusion that you need to take away from this lesson. There's the main point. These are reciprocals. And this should make sense because the slope of any graph is calculated as the derivative, delta y over delta x, the change in your y values over the change in x. Well, if you switch x and y, isn't the slope of the inverse going to be the reciprocal? The change in your x over the change in y? So that's the connection, and that's the big idea that we're going to use today. All right, so what I'm going to do is I'm going to run through some examples about how we can find derivatives of inverses. Now, the first one is what I call blunt force trauma. We're just going to take a big bat, and we're going to hammer out or beat out the derivative. And our method, our approach, is to find the inverse. If I want the derivative of the inverse, I'm going to go ahead and I'm just going to find the inverse. And then I'm going to calculate what the derivative is. Okay? And we're only going to use this when we're given an equation for y equals f of x. And we can find the inverse. If you can find the inverse, sure, go for it. So we'll go ahead and look at this approach. Here's our steps. Find the inverse function, take the derivative of the new y value, and then plug in the given point, okay? So we're going to go ahead, we're going to find the inverse function. Step number 1, and we do this by interchanging x and y. So let's look at example number 2. Let f and g be inverse functions, where f inverse of x is equal to g. Okay, so f and g are inverses. And then they say if f of x is equal to x cubed minus 1, find g prime of 7. I want the derivative of g. I don't have g, but I know that f and g are inverses. So if f of x is equal to x cubed minus 1, I can go ahead, I can find the inverse by switching x and y. So I set my equation equal to y, I switch x and y, and then I'm going to go ahead and I'm going to solve for y. So I'll add 1 to each side. The x plus 1 is equal to y cubed. I'll go ahead, I'll take the derivative, or sorry, not the derivative, the cubic root of x plus 1 on both sides. So y is equal to the cubic root of x plus 1. This is g of x, the inverse. Cubic root of x plus 1. So that is step number 1. Step number 2, take the derivative of this. And the cubic root of x plus 1, hopefully you know that that's just x plus 1 raised to the power of 1/3. So g prime of x is equal to 1/3 times x plus 1 raised to the power of negative 2/3. Negative 2/3. Okay, now they say find g prime of 7, and then this is step 3. Just plug in whatever they want you to find. G prime of 7. Okay, so this is 1/3 times the cubic root of x plus 1, so 7 plus 1, and that quantity is squared. You can square the radicand, you could square the cubic root, both of them are equivalent. But if we go ahead and compute this, this is 1/3 times the cubic root of 8 squared, which is just 64, which is 1 divided by 3 times 4, which is 1/12. And there is our derivative. Not super elegant, kind of old school, find the inverse and then find that derivative, but it works. Example 3. If f of x equals e to the power of 2x, find the derivative of f inverse of x at x equals 3. Okay, so they want the inverse derivative at 3. So what I need is I need to find the inverse. Again, this is step number 1. E to the power of 2x, I'm going to set it equal to y, and then I'm going to switch x and y. X is equal to e to the power of 2y. And maybe at this point you're freaking out. You're like, how the heck do I solve that? Well, I'm going to say, okay, what's the inverse of an exponential? How do you undo an exponential? And hopefully logarithms pop into your mind. Maybe right now you're freaking out. It's not that bad. The logarithm that we're going to use matches the base that I want to undo, and that is the natural log. So we'll take a natural log of each side, and we get the natural log of x is equal to 2y. Okay, and then to solve for y, I'm just going to divide by 2, so 1/2 natural log of x. If you really want to write it like this, you can. They're both the same, but this is f inverse of x. Okay, and then now what I'm going to do, okay, that was step number 1 again, right? Step number 2, now find the derivative. F inverse prime of x. And this is where I really like the first representation here, y equals 1/2 natural log of x, because 1/2 is a multiplier, so 1/2 times, and then what's the derivative of natural log of x? 1/x. So here's our derivative, 1/2x. And you'd get the same thing if you did this, right? The natural log of x, the derivative is 1/x. So 1/x all divided by 2, you end up with the same representation. Okay, so step 3, now let's go ahead and calculate the derivative of the inverse at 3, which we get 1/2 times 3, so 1/6. There it is. That's it. This is the method that you use when you can find the inverse and you feel like doing it. I wouldn't say this is as common on the AP test. We'll get to the examples that are very common in a bit, but I want you guys to have some practice. So go ahead, please pause the video and try this example. Alright, hopefully you went ahead and tried this example. Here is the solution. The first step, if you know that h and k are inverse functions and you need to find k prime, well, that's the inverse of h of x. So I'm going to find the inverse of h, and that ended up being 3/2x plus 6. The common error for people in this problem, remember when you're going to cancel a fraction, a numerical coefficient that's a fraction, you multiply by the reciprocal to both sides, and I have to distribute this to every single term. So if you do this correctly, 3/2x plus 6. Well, now I got to take the derivative of that. Very simple. The derivative is 3/2, and then of course the derivative at 5 is going to be 3/2. That's a constant function. All right. Here is method number 2, and the most common, I believe, utilized on the AP test. Now, you're going to go ahead and use this idea when you're given a equation for f of x, but finding the inverse is difficult. It's a function, quite frankly, that looks very, very ugly. Or it's impossible. Information about the function is not even given, i.e. a table of values, okay? And what we're going to use today is what we discovered in the beginning, is that inverse derivatives are reciprocals. Inverse, or I guess I should say derivatives of inverses, derivatives of inverses are reciprocals. That's the main idea, okay? So, how does this idea work? Well, we're going to go ahead and start with let f be a function that's differentiable. If f has an inverse function f inverse, then f inverse is differentiable at any x for which f prime of f inverse of x does not equal 0. Okay? And f inverse prime of x is equal to 1 over f prime of f inverse of x, or here's the main idea here. Or if g is equal to f inverse, then let g of x equal y, then g prime of x is equal to 1 over f prime of y. Now this looks like gibberish, but it's really, really straightforward. If g and f are inverses, and I get this point, x comma y, well then the point for f is going to be y comma x. Okay? And the slope of my inverse is the reciprocal. So g prime of x is equal to the reciprocal of 1 over f prime of y. So let's go ahead and let's put this into practice. Let's see how we can use this idea. All right, example 4. Let f be the function defined by f is equal to x cubed plus 2x squared plus 1. Let g be equal to f inverse, where g of 1 is equal to negative 2. And we're asked, go ahead, find the value of g prime of 1. Okay, so first of all, I have to find the derivative of an inverse. Can I go ahead and take an inverse of this function? That looks really, really ugly. I don't want to touch that. So what I'm going to go ahead and do is I'm going to use the knowledge that derivatives are reciprocals. And what I'm going to do is I'm going to find f prime of x. I'm going to use this derivative, 3x squared plus 4x, and I'm going to use that idea to find the value of the derivative of the inverse. Now, for my point at g, if I'm looking at g of x, the x value of 1 gives me negative 2. So if they're inverses, then the inverse of this would be negative 2 comma 1. Okay, so what I'm going to go ahead and do is I'm going to plug in negative 2. I'm going to plug in negative 2. Negative 2. So f prime of negative 2, and we get 3 times negative 2 squared plus 4 times negative 2. And this gives us 3 times 4, which is 12, minus 8, which is equal to 4. Okay, so how does that tie into my function g prime of 1? Well, this point, 1 comma negative 2 and negative 2, 1, they're mere points. So the derivative at this mere point, the inverses are going to have reciprocal slopes. So I have g prime of 1 is equal to the reciprocal of 4, which is 1/4. And there you have it. Example 5. This time they say let f be differentiable in an increasing function. Selected values of f and its derivative are given in the table below. If g is the inverse function of f, find the following, if possible. So they're going to ask us some questions about g prime, but notice I'm not given any information about g. I'm just given a table of values about f. So what I recommend doing is making this table for all of these problems. If you get a problem like this on the AP test or on your homework, I want you to make this table where you have f of x and g of x, and all you're going to do is list the points and their slopes. So this table of value, they say, okay, when x is 0, f is negative 2. So I just fill that in. And the slope is 3. I'm just reading this table. Okay, when my x value is 3, my y value is 6, and my slope is 2. Okay, when x is 6, y is 21, my slope is 7. Okay, so how does that give me any information about the inverse? Well, how do you find the inverse? Switch x and y. So I'm going to go ahead, I'm just going to switch these x and y values. I get negative 2, 0, 6, 3, 21, 6. And their slopes, well, the slopes at the mirror point are going to be reciprocals. So the slope at this point is going to be 1 over 3. 1 over 3. The slope at this point is going to be the reciprocal of its mirror point, which is 1 over 2. And the reciprocal of this mirror point, or sorry, the derivative of this of the inverse of this mirror point is going to be the reciprocal, 1/7. Okay? So this table of values, now it's just like reading from a table, which is super easy. Let's check this out. What is g prime of 6? Okay, so what is the slope at the point 6? Well, I go to my table. Here is 6, and what's the slope? 1/2. Very easy. For b, g prime of 21. I look at my table, I find 21. The slope is 1/7. 1/7. G prime of negative 2. Okay, so I look at my table, negative 2. Slope is 1/3. Okay, and d, g prime of 3. Looking at my table, do I have any x values that are 3? No. So we would say not possible. Or cannot be determined. Cannot be determined. Undefined? I mean, it's not defined in the table, so undefined. Okay? So look out for questions like that where you don't have any information, but more than likely the information is going to be given. Okay, so here we go. Here is the last practice problem that I have for you. Please go ahead, pause the video, and give this example a try. All right, here is the solutions. Hopefully you got this value for A. The slope of g at 1 is 2/3. G prime of 2 is 1/2. C is not possible. You're not given any information about g of negative 1. And g prime of 5 is equal to 2. All right. Now that is finding the derivatives of inverse functions. They're reciprocals. You use the mirror point and the slopes are reciprocals. Give me a thumbs up, like this video, go ahead and subscribe for more awesome math videos. Catch you in the next one. Peace.